We have exactly 2 p.m. So we start in time because we have a lot to show today to you, 45 slides. And we're also looking for your feedback, your questions. So I think we should go directly in the presentation. We have in total 100 participants registered. Now we are 36. So a few will come a little later, but that's fine. Today, the session will be run by Pia Sosinski and me, Michael Karos, CEO and founder of Nova, and Pia is the main author of this great report we show today. Before I start, just one comment. Please use the question and answer part in Zoom. You can find it on the bottom in this black desk board for your questions. And Pia and I will try to answer your question in this system, or we take it up and read the question and discuss it in the public here. But your comments and questions are very welcome. If you want to comment other things and questions that you hear no sound or something, you can also use the chat. Christian, who is also here from Nova, will also keep an eye on the chats. Yeah, today is goes a deep dive on bio-based building blocks and polymers. Before we start with the study, I give a little background. Who is Nova? Nova-Institut was founded in 1994 from 4 or 5 scientists. And meanwhile, we have nearly 50 scientists in Nova, and we're working on bio-based solutions, CO2-based and recycling, especially chemical recycling. But today, the clear topic is bio-based. Our mission is support companies in the smart transition to renewable carbon, so switching from fossil carbon to renewable carbon. And bio-based is one of the three very important pillars for this transformation. Nova is working mainly in 4 departments. The Department of Technology and Markets, where Pia is also part of, work mainly on market research and technology scouting. So exactly what's the topic today. We have other departments like sustainability. They're doing life cycle assessments, mainly for chemicals and polymers and plastics. So they have their own workshop running parallel to this now on life cycle assessment methodologies. Then we have a department communication. It's organizing events like this. And also, that is important, if company is doing great development, they need also the right communication to the market, to NGOs, to policymakers. Here we're supporting a lot of companies. And last but not least, economy and policy. We have a very strong policy team, so we know very well what's going on in Brussels. The future framework for bio-based polymers is getting a little better. And if you have later questions to this topic, I can also cover these questions. But in the focus here is the department of Achim Raschka. He is the head of the department. He's today in Copenhagen. His department is, as you see here, market research, market trend report. So exactly what we're looking for today. Here you'll see our latest reports. So they are not only on bio-based building blocks, also on naphtha, on biodegradable plastics in China, on chemical recycling, on CO2 utilization, on PHA, and many others. But on the top left, you see the latest report, and this is from bio-based building blocks and polymers. And to have a deeper dive, what we're doing here, it's a big team. Meanwhile, you see the expert team, and the experts are located in US, in Asia, in Europe, in different countries, in China especially also, but in many, many different countries, so that we can cover the development of the investment and capacities on the world level. Today, we can in 1 hour only show you some insights of the report. The full report has meanwhile 434 pages, backing up, covering 17 bio-based building blocks and polymers, capacities from 2018 till 29. And we have also included mass balance and attribution polymers. I will also have later part on this one. It's very unique data you can see here. We have also special topics, each polymer and also each company. We will later present some slides where you see how the report looks like, how deep information you can find here, 218 company profiles, and of course it's 17 polymers and 60 features and 50 tables. You can also get a short version of the report if you go to this link here, renewablecarbon.eu commercial reports. You find also a link to the free version where I think on 24 pages you get the main results, but to get the real deep dive, of course, the big report is a fantastic solution. And I think everybody who want to invest in the sector, who want to make marketing and business plans, should have the full access to the comprehensive information on the market. And today we will show especially the summary of the main trends. Here you have the first picture. We cannot go here in detail, it's a complex picture, but the idea is that you see in the middle the feedstock. These are mainly waste oil, saccharose, natural rubber, lignocellulose, non-edible milk, plant oils, starch. So a wide range of bio-based feedstocks producing from these intermediates, building blocks, and then on the circle, on the outer circle, also all the polymers. There are sometimes different pathways to different polymers from different feedstocks. So this picture already is a very complex picture we could discuss, but we now zooming in most important results. And I will give the overview, and then to the in-depth calculator discussion, Pia will take over. This picture at first gives an overview about the 17 polymers, because you can group them in 3 parts. This is important to understand because also the land efficiency, the policy framework is different for the different types of polymers. On the top level, you have drop-in polymers. That means that they finally are the same as the fossil counterparts. And then we have 2 types of drop-ins. One drop-ins, you start in a very early stage, for example, with alternative naphtha or biogas or syngas from biomass. So you start, you're mainly training the feedstock of the process, but you keep the process like it is today in the fossil world, ending up then with identical polymers, but you only change the feedstock. In the smart drop-ins, epoxy resin, polyamides, PBIT, PBS, PTT, and polyurethanes based on other polyals and NOPs. Here you have also finally the same polymers, but the process is completely different. So epoxy, for example, is made from glycerol, so it's a complete other process than coming from fossil resources, but finally you have the same polymers. This is important also for recycling. So for drop-ins and smart drop-ins, there is no issue with recycling because they are recycled like the fossil counterparts. For the dedicated polymers, these are polymers which are only made from biomass, so there is no fossil counterpart. Cellulose acetate, PEF, PHAs, PLA, the natural oil polyols, and starch-containing polymer compounds. These are specific polymers. Some of them, like CA, also older. They are not invented in the last 20 years, but they was always made from biomass or a lot of new polymers, as you see also here. And another point in this graph is the biodegradation, and the green dots showing which of these polymers are biodegradable under certain conditions. And we will later also give a deeper view in the different end-of-life options of polymers and which can cover which final biodegradation in different environments or recycling. Yeah. So this is the first overview. If you have already some questions, please drop your questions. We are happy to receive questions. We see a lot in the chat, but Christian told me that he will copy the questions from the chat in the question and answers. Christian, is this right? Okay. Yeah, so I hope so. So if you have questions, please use not the chat, but the question and answer. And Christian will take a look to the chat whether there are questions better in the other options. I take a quick look at the chat whether there are questions, because if there are no questions, we should not. Here is a question already. Which feedstock is the one that is the most cost and energy efficient for PLA? Yeah, this is a very special one, but we come later to this, but I can give a quick answer. Of course, these are sugar and starch are the most efficient ones from corn and from sugarcane, sugar beet. If you use second generation sugars, then the price is something like double. So give a first quick answer to that. Coming to the next slide. Yeah, here's development of bio-based building blocks. These are mainly building blocks which are used for polymers later. So we have also other building blocks, of course, but these building blocks are directly related to polymer production. But some of them, also like lactic acid, for example, are also used in other sectors, like food and feed. Here you'll see that these new building blocks have a very nice development over the years. A very high growth rate per year. So they really have more and more applications in polymers, in food and feed, and other chemicals, some in surfactants or detergents. So this is a really success story. And what is most important here in the success story, Pia will explain in the next slide where the main development coming from.
Yeah, thank you very much, Michael. So if we look to the development from 2023 to 2024, we have an increase of 800,000 tons in the capacity of these 17 bio-based building blocks. And the main drivers for this increase to 2024 were mainly naphtha with a worldwide expansion, as well as lactic acid for PLA, dodecandiolic acid for polyamides, as well as epichlorohydrin for the epoxy resins, and 1.3 propanediol for PTT. And all of these latter four building blocks have mainly seen expansions in Asia from 2023 to 2024. The next slide, please. So in 2024, we had an installed capacity of 5.6 million tons, and this capacity is expected to increase to 10.5 million tons until 2029, which reflects a compound annual growth rate of 13% for these bio-based building blocks. And the main drivers for 2029, or the capacity increase until 2029, are again lactic acid with expansions in Asia and also in Europe. We see worldwide expansion for ethylene, as well as a worldwide expansion for propylene. Again, in Asia, epichlorohydrin capacities will increase or are expected to increase, as well as North American installations, new installations for monoethylene glycol production, and North American and Asian expansions for 1.4 butanediol until 2029. Yeah. Next slide. Should I hand back to you, Michael, or?
I will start and then you take over. So it's interesting if you see statistics about this polymer and plastic production or capacities, you will see it seems so that Plastics Europe, European Bioplastics, and Nova have different numbers. But in fact, is that all the numbers coming from nova-Institut. So we providing the data to Plastics Europe, we provide the data to European Bioplastics. So there is one source meanwhile. So there was some competition between different institutes who can deliver the best data, and we was finally the winner. But why this data are so different from 2.2 million, 1.8, and Nova 4.4? So Pia will explain the main reason for this differences.
Yeah, the main reason is quite simple. All of the three parties have different scopes in which polymers and plastic they would like to include in their data sets. So we as Nova provide the data on all 17 commercially available 17 bio-based polymers and 10 applications, or the 10 applications they are used in, while European Bioplastics only covers 14 polymers and also the 10 applications they are used in. And Plastics Europe focus only on the plastics or the polymers that go into plastic applications. So they have 16 plastics and 8 covered applications. So this is the main difference in the overall published number of the volumes for the plastics and polymers. And if we look at when the data is published, so European Bioplastics always goes first with the data of the current data year in December. Then we follow in March of the following year. And later this year in autumn, Plastics Europe will publish their plastics, the fast facts for 2024.
Concerning the applications, is always the question whether to include fibers, textile fibers. We have, of course, included them because they have from building block to polymer to fiber, it's almost the same pathway. But this, for example, Plastics Europe has not included fibers, and this is one of the differences in the statistics. So thank you, Pia. And so be not confused. If you need all data, just take our data. And if you take the others, be aware that there are sub-data of the total data set. Now we're coming to the plastic production. This picture shows the global plastic production, and it's still increasing with something between 2 or 4% per year. We have a special demand from developing countries. For example, if you're looking to food security, we see often that there are a lot of food losses in the value chain because there is not enough packaging available. And so to increase packaging in Africa, for example, will increase food security, and they need additional packaging and, of course, also cooling systems. These are the two main points, not to losing too much from your harvest in the beginning. And also the people looking for more comfort in their life, and that also means they have more products, more textiles. So we think that will be continue. In the past, this was an annual growth rate by 3 to 4%. It could happen that it goes down to 2 to 3, but in this order we can expect. We see the share of Europe is not only the share, even absolute numbers for in Europe are decreasing. This is the dark blue. We will see whether this can change again. And on the top, you'll see a not easy visible green part. This is the bio-based part with 4 million. It's about 1% of the total production market production. And there we zoom deeper in the next slides. This picture here is the only picture giving the very big context, because we're looking in all the statistics to the structural polymers you find in the middle of this picture here. These are the numbers which are communicated and from Plastics Europe, for European Plastic or for Nova. But if you look to all polymers available, we have also functional polymers with a high share of bio-based, 44%. This is paper starch. So all paper need a polymer to work, and this is paper starch. And if you would not use paper starch, they have to switch to a fossil polymer. So it's a really important share here. Then we're looking to rubber products also in the middle. There are 51% bio-based, so it's also a very important part. And man-made fibers, there are mainly cellulose fibers and of course also PLA fibers and some other biofibers. And if you look now to the picture to all polymers, not only the structural polymers means, by the way, that the polymer is responsible for the structure of the product. When functional is more a function, is not the structural part of the product. And if you look to all, then you see the share of polymers is already including functional, structural, rubber, and man-made fibers, already something like 8%. But the sector we are looking here is structural, there's only 1%. Yeah, no questions so far. Here we see this picture of the structural polymers, but it was normally we say just bio-based polymers, but for the links, these are the structural part. You see the 17 commercially available. You see the growth rate is 13% per year. In comparison, the fossil ones about 3%. So that means if this will happen, and this is based on surveys from the leading companies. So we have contact to a lot of companies, so more than 200 companies, and so this is based on the forecast of the companies. If there are additional companies coming, and this is happening, for example, in Middle East or in Thailand, Malaysia, Thailand, then it will adding additional capacities here. We cannot ask companies will be only there in 2-3 years. So this is the minimum we could discover. And the question here, how high is the compounded annual growth of PLA? Yeah, this is later a deep dive Pia is doing on the next slide. Next slide showing more details. Other question, lignin. Yeah, lignin is in principle included here, but lignin is so far not a relevant share in polymers. It's just a few startups. We see now a lot of development in lignin, so we expect in 5 years we see also lignin here, but we have to wait a little bit here. Why are conventional polymers decreasing? Now, that is not the case. If you look to the picture here, the total growth rate is still about 3% per year. And if the bio-base will come from 1 to 2% perhaps, there's still an increase in fossil one. So we are not so far that we're really replacing the growth from fossil with bio-based. We hope that will happen, but this is not yet the case. Yeah, when we look to this picture here, we have growth rates for different polymers. They are in different huge or smaller. And this is exactly where Pia take over. The next slide showing more details, who is responsible for this development.
Yeah, thank you, Michael. To answer directly the question on the CAGR of PLA until 2029, it's 22% for this specific polymer. And yeah, the overall CAGR is 13%, as Michael already mentioned. So for the development from 2023 to 2024, so in 2023, we had an installed capacity of the bio-based polymers of 4.6 million tons. And this capacity increased to 5.2 million tons in 2024. And here at the bottom of the table, you can also see the production. So the actual production in 2023 was 3.9 million tons. And the production in 2024 was 4.2 million tons. So we have 1 million ton of, let's say, discrepancy between capacity and actual production in 2024. This is due to large installed capacities and relatively low utilization rates for bio-based polymers that have large installed capacities, as for example, PLA, because we assumed the actual production or utilization rate of all the PLA plants in 2024 of about 35 to 40%, and therefore we have this high discrepancy in production and capacity for 2024. But the main drivers for the capacity increase to 2024 were Asian expansions in PLA capacity, despite the low utilization rates, as well as Asian expansion in epoxy resin production. Also in Asia, expansions for polyhydroxyalkanoates and polytrimethylene terephthalate.
There are interesting questions here in the chat. And the question and answer, one is the one compared the forecast now with the forecast last year, and there is a decrease in total million. I think this is mainly for the correction on PHA capacities, right?
Yeah, and also for PLA capacities. So each year we look at the capacities that we have listed in the previous year and do a deep dive on if the company still exists, if they reach their target to increase their capacity until 2028 or 2029. And for last year, we had to do a large number of excluding companies and correcting the numbers. Yeah, therefore we have this difference.
Yeah, and before we come to the next question, we first go to the next slide.
And the forecast until 2029, so a compound annual growth rate of 13%. So it is expected that worldwide total bio-based polymer capacity will reach 9.5 million tons. And the main drivers for this increase are, again, new capacities for PLA in Asia, but also in Europe. There will be this large European refinery of Futero in France, as one example. We also see worldwide capacity increases for PHA. But here, please keep in mind, this is the data for 2024. So the announcement of Denmark to close plants is not included in this data. So this will be then updated for the 2025 data next year. Again, also expansions for epoxy resin in Asia, and there will be new installations for polypropylene production in North America, as well as for polyethylene in North America and in Asia.
There are some questions I would like to take. One is, what does justify the rapid increase in production capacity, PP, PHA, and PLA? I would answer that this is mainly happen in Asia and also in China, and their capacities are not fully utilized in production. But we see, especially in Asia and Middle East, that there are some policy frameworks supporting the uptake of the market. In China, they're also expected to export more to Europe. We see first quota discussion in the automotive sector in Europe. It is often the policy framework and expected demand in the future, but perhaps you can add a comment from your side.
No, it's
Okay.
mainly Asia, especially for PLA and PHA, but also there is this large North American installation that will come up for polypropylene, I think with about 400,000 tons expected in 2029, but it's a forecast. So we will see if this 400,000 tons of polypropylene will be really installed until 2029. Yeah.
And some two easy questions for you, Pia, I think. Is PLA through lactide route?
Yeah.
And
yeah.
Is copolymer also projected here? Are copolymers also included in the data here?
Copolymers, yes, specifically for the starch-containing polymer compounds, because starch have to be compounded with other polymers so that you can use starch. So we have PBAT, PLA, PHA, mainly being compounded with starch. And therefore, in some cases, we might have double counting here. But we have taken care of this, I think, 2 years ago in the data sets. So we assume a starch, a final starch content of only 30% that we visualize for the starch-containing polymer compounds, and assume that the other 17% are covered by the compounding polymers as PBAT, PLA, and PHA. So in the overall figures, you will only see the starch content for the starch-containing polymer compounds, and the other volumes from the compounding polymers as PBAT, PHA, and PLA will be covered in the respective polymer sections, so that we do not have this large amount of double counting here.
Yeah, and then I will give quick answers to other questions. In Asia, we look into all Asia. We see activities in Thailand, Malaysia, and a lot in China. This is all covered. There is not one specific country, but there are different countries now starting. India is now starting also with production of bioethylene, for example, for PE. So it's a wide number of Asian countries, and later we show you a slide about the share of Asia. And the other question on competition on sugar, we have later a slide there, so I will comment this later. So I go now to the next slide. So thank you for your questions. Perhaps did not cover all questions because we want to show you a lot of slides first. This picture here is showing that not all 17 bio-based polymers are fully bio-based. So from the definition of SEN, if a polymer containing more than 20% biomass, then you can call it a bio-based polymer. But you see here, cellulose acetate, for example, is half-half. So these are the gray lines here showing for the different polymers what is a fossil share in the total polymer. For PLA, it's 0, but for others, it can be a mixture. So more you see in the brochure, in the leaflet, but just to give you a quick impression that it not mean automatically that there are fully bio-based, partly bio-based, is also counting as bio-based polymer. Now we look into the development of the non-biodegradable and the biodegradable polymers. I think I take it, yeah. Yeah, I think perhaps we can make a quick overview, Pia, because we have so many other slides to show. But so the main message from your side on this slide or the next.
Yeah, so for the bio-based non-biodegradable polymers, we have 10 of them, and we had an installed capacity of 2.8 million tons in 2024, and this is expected to grow until to 4.5 million tons in 2029, and we have an expected compound annual growth rate of 10% here. And on the next slide, we have also the development from 2023 to 2024, and as you can see, these are mainly also the polymers that were already mentioned in the complete overview. But here specifically, we have also worldwide expansions for polyurethane and an Asian expansion for aliphatic polycarbonates capacity from 2023 to 2024. And we have a similar picture for 2029. Again, here, for example, the new installations for polypropylene in North America, but also epoxy resins in Asia and polyethylene in Asia and North America.
And perhaps to add, the epoxy resin are made from glycerol. Glycerol is a byproduct from biodiesel production. So as long as biodiesel production grows worldwide, we will see here as a side stream a lot of epoxy resin based on it. Often the epoxy resin from glycerol is even cheaper than the fossil one. Most of it is not labeled because then you avoid a lot of questions, also questions we see in the chat. So the market is much bigger than you see with a green label because many companies just doing it, selling it well, and it works well. But as soon as the biodiesel production will decrease worldwide due to electric cars, then we will also see an impact on the epoxy, bio-based epoxy resin. This picture here gives a nice overview. You can download this also from our webpage. Overview about the different biodegradation options. We've not to spend too much time here, but you see we have different environments here: marine, freshwater, soil, home composting, landfill, anaerobic digestion, industrial composting. And here you see different polymers in which environments they really biodegrade. Cellulose, for example, with low lignin in all environments, but PLA or PBSA or PBS only in specific environments. This is an own webinar to go here in detail, but that's aware when we talk about biodegradation, we always have to say in which environment. The environment is here crucial, and there are only a very few polymers with a good biodegradation in all environments. One comment to cellulose acetate, you see the cigarette filter are one of the main applications. It can be produced from CA varieties which are biodegradable. That would be nice. But here the problem is nicotine in the filter is also a barrier for biodegradation. So even if the CA is biodegradable, together with nicotine is not easy biodegradable for the bacteria. But this just for a quick view. If you need more information here, download the picture and you can read a lot of details on certifications and everything on this slide here. Yeah, now we go into the bio-based biodegradable polymers. Just some of them we saw on the picture before. And here again, I would pass over to Pia to show you the main ideas of this graphics.
Yeah, so for these 7 bio-based biodegradable polymers, we have an even higher expected compound annual growth rate until 2029 of about 16%. So the installed capacity of 2024 of about 2.4 million tons will increase to nearly 5 million tons in 2029. And if we look into the development from 2023 to 2024, we had a capacity increase of 400,000 tons and an increase in production of 100,000 tons. And also here you can see that we have a rather high discrepancy between installed capacity and actual production. And this is, as I already said, mainly based on the low utilization rates for PLA, but also for polyhydroxyalkanoates. Nevertheless, The main drivers until 2029 are new expansions or new installed capacities and increases for PLA in Asia and Europe, as well as worldwide for polyhydroxyalkanoates.
Yeah, in the question part, we see the question on packaging waste regulation and single-use plastic directive. So far, they're giving only incentives to recycled material, but there are under discussions to include perhaps a bio-based quota, and also perhaps in the single plastic directive, also take a look to the origin of the carbon. This is not yet the case, and we are also with Renewable Carbon Initiative active in different committees and meetings with the Commission. And this year, with the starting point of new discussions and revision of these regulations, but it's too early to say what will be the final result of this revision. We do our best to include bio-based solutions, but again, this is the future and it's just starting the discussion. Then there is a question, a very specific question to Pia. Is polycarbonate aliphatic includes polycarbonadiol or specialty diols?
As far as I know, the majority of the companies, there are not that many, use isosorbide as a bio-based diol part, and also derivatives from castor oil as a diol part for the polycarbonates.
And the question to the mega trends, the mega trends are very different in the different regions. So we come here to the different regions, and we see political framework developing better in the direction of bio-based in Middle East and Asia compared to Europe. So that's the reason you see here the picture. Asia has meanwhile a share of 59%. The share of Europe and North America is decreasing, and this is mainly due to a policy framework. It's not the right place now to talk in detail on the framework in India, the framework in Saudi Arabia, the framework in Emirates, the framework in Malaysia, but they're all, or also China. There's own report only on the Chinese market, but we see if there is a certain framework to support, to create demand, then the investment goes to these regions. And we are working with Nova and RCI strongly. We have just published a paper with 10 instruments how to increase demand, because we have an implementation gap in Europe. And if we together would be able to develop quotas for automotive sector, for packaging sector, then I'm pretty sure that investment comes back to Europe. But this is not yet the case. And the other questions, substitution and with application, we'll see later a picture about the main applications. Many of these new polymers can substitute a lot of other polymers, especially if we have today a market share of 1%. To go into 2, 3, 4, there are many different options for substitution. And this really, as a serious discussion, where are the limits, will come much later. So in the moment, we have still, in principle, many growth options as soon as the political framework fits. Here you see the different sectors for all the polymers. You see fibers are an important part of it, but also packaging. The packaging and fibers are the most important ones. Then we have these functional applications, consumer goods, automotive, building and construction, electronics, agriculture. So in principle, if companies come into nova-Institut, experts to PIA, for example, and they say, we have a certain application, we would like to use a certain polymer, is there a bio-based option? In most cases, we can offer an option. We have also some special polymer science experts in Nova that they can really also look to the exact properties. So there are many options, and in many cases, the fossil polymers, the properties of fossil polymers are not fully necessary to do the job in the product. You have a lot of over functionality in many products, so there are a lot of substitution options. But as you see in this slide here, normally you can find for almost all applications a bio-based solution, and not always PLA, of course, but we have 17 options here. And here you'll see it even more in detail. This picture is normally only available in the full report, but we say today we shared with you, because here you can see per polymer where are the most applications, as I quoted already, cellulose acetate. Here you see the brown part are fibers. So 90% are used today in cigarette filters, but more and more also new application for CA, because the cigarette market is not increasing anymore. So you're looking for new applications. Can look to PE, to PET. So I don't want to go to all the details here, but you see the information is there in which markets specific polymers are mainly used. In PLA case, as a last example, there you see fibers. You see, especially in the North American market, we have a lot of textile applications for PLA. You see packaging applications, flexible and rigid. You see consumer goods, for example, toys. You see the next one, agriculture, horticulture, mulching films. You see electronics. So PLA, an example where it's already in many different applications on the market. Yeah, perhaps you will give here a short overview, Pia, what is most important here?
Yeah, it's just another visualization of the graphic before, so that you can see which are the polymers with the highest variability in the applications where they are currently used in. So we have here the bio-based and biodegradables. Michael already mentioned PLA, nearly used in all of the 10 applications we cover here, except for building and construction and functional applications, but also PHA and PBS as bio-based and biodegradable polymers have large variability in applications, and also these three as the bio-based non-biodegradable polymers, epoxy resins, PA, and polyurethanes are used in 5 applications. Whereas on the other hand, you have these 3 bio-based and non-biodegradable polymers, EPDM, PET, and what's the last one? PTT, okay, yeah. They are only used in 1 to 3 applications and have, very low variability in which application they are used.
But they can nevertheless have a big volume in these applications because they're fitting so well in these applications.
Yeah.
I think also the textile market is an interesting market for the future, because they have not easy to the share of fossil fibers in our textiles is increasing every year, and the textile sector is looking strongly to new alternatives, and they love polyester fibers. So bio-PET fibers are an interesting option for the textile sector, just to give one example. Yeah, when we're looking here to the feedstock questions, this was also questions was in the question part already. We see here worldwide biomass production 13.6 billion tons. The bio-based polymers take 0.023%. So if anything has an impact on biomass, it's not the bio-based polymer sector. And even if it goes times 10, it was 0.2. So this is really not impacting anything. You see, as usual, that there is most biomass go to feed, to meat production, but not only to meat, also to milk and cheese. So the footprint of cheese is almost high as the meat footprint. Many people don't like to hear this, but it's proven. Then you have bioenergy, food, material, other material use. There's also bedding material for animals. It's also in this green part. Then biofuels. And on the right-hand side, you see on other feedstock, you see a glycerol is the very important for epoxies. Then you have sugar and starch. So sugar and starch are still a very important part in edible plant oil. And whether this is a good idea or not to use food crops is a complete other webinar. I also are responsible for this topic, so I give only one aspect here. If you grow food crops for industrial purposes, they are not a threat to food security, but in contrast, they support food security because you have an emergency reserve you have not to pay for. So that means if you have a crisis, if it's really one day a starch or sugar crisis, then you can just take over from the industry, and then the industry cannot produce polymers 6 months, but you can feed the population. And this is exactly what happened already in the Ukraine war. There was a gap for plant oil for cooking because the export from Ukraine was stopped. And then in Germany, they stopped to use plant oil in biodiesel production and redirected it to the food market. So it's not only a theory, it worked in practice. And so we should be very careful to invent here a conflict situation. It's much more complex. And if you are interested in this topic, I'm happy to give you another hour on this topic. But here, this I think is first enough. And another point is here very important. If you look to the written part at the bottom, the share of land is even lower. So the share of land is not 0.02, it's only 0.013. It's even lower, and the reason is they're using high-yielding crops like sugarcane and corn. And we have some feedstock like glycerol. They have not an own land share because they're a byproduct from biodiesel production. And last not least, in most of the crops, you produce at the same time proteins for the food market and sugar and starch for the industry market. So that means we also have to allocate the areas to both markets, and we are rare in proteins, not in sugars. So you have always if you use corn or wheat, you have always a huge amount of proteins for the food and feed market. So it's not a black and white situation, it's a combined situation, just to give a first view on it. But you see here, we have all the data and all the details. So if you need more information, please come to us. So the last part is here. See, there are some new questions here. Is it true that biodegradable polymers are difficult to use under heavy weather conditions? PLA is not so easy biodegradable. PLA need also a certain temperature. If it's a fast biodegrade, it needs a certain temperature. You have only in industrial composting. So even in home composting, PLA is not really nicely biodegrading. So that means PLA needs certain conditions to biodegrade very well. And if you just use it in a toy and you keep the toy in a dishwater machine or the toy outside in the garden, it takes a long time to biodegrade. So that is not a problem. But this is a very specific topic, and we are happy to give you more information here. But PLA is not an easy biodegradable. If you have a starch-based polymer or some PHAs, here it could happen that the biodegradation is much faster. To come to the last point here, I think this is also an important point here. In cars was here. Okay, they're using in the car mainly PLA as interior polymer and not for the bumpers, for example. So I think this is where it works very well. In Japanese cars, PLA was already 10 years ago in the cars to test it as a carpet material or door panel material, and it works well. Outside in the car, this is not the main favorite application for PLA. Yeah, the last part is also a very important part because I don't know whether it's starting with this picture here. I think there was one picture missing here. Yeah, okay. When we look into the, I think I start with the next one. I think I put here the wrong slide in. Sorry for that. But you know, many of you know also that we have this mass balance attribution part. So that means that you replace in a cracker system the fossil feedstock by biogas, by sugar and starch or whatever, or alternative naphthas. And then you attribute the feedstock amount you put into a certain polymer at the end. And so you cannot measure the full bio-based part. If you measure it, it could happen that it's only 2% or 1%, but to a very good certificates, meanwhile, there is a process to attribute the feedstock input to the final polymer. And then you can also say this is a 100% bioattributed polymer. And then the feedstock is not attributed to other products, but only to this one polymer. And this is a solid system today. And they have also to keep in mind that you cannot attribute the losses, not the fuel part. This is all regulated today. This environment will be soon have a final version of this concept, but you can already today certify it with ISSC or Red Cert or RSP. And this market is strongly growing. And the slide I have, the wrong slide in, is showing that the share of those products was tripling with ISSC certification, was tripling from 200,000 to 600,000. So this is a fast-growing sector in the bioattributed sector. And the report is also covering this topic here. And this is for many companies very important. And you see on the first slide here which building blocks and chemicals are on the market based on this mass balance attribution system, a wide range, and this was much more limited in the past. And you can also see which polymers on the market are here produced. PE, PP are the most one, but also EBS, polycarbonate, SRN, styrene butadiene, and so on. You see it here up to polystyrene. And this is really a strongly growing market, and we can discuss also, we have a few minutes, is this a good idea or not? The advantage here is, two advantages here. First one is, you are really replacing fossil carbon as feedstock with biomass. This is guaranteed in a solid certification system. The second is, you can come quickly to big volumes because you just have to change the feedstock, but the whole system is cracker and downstream processes stay the same, so you can use the existing infrastructure of the chemical industry. These are the two main benefits here. And so also big units can start replacing 1%, 2%, 5%, 10%, but they can label already some of the products with 100%. The disadvantage is a little bit that they are normally cheaper than the really bio-based pathways. And so there are a little, could be a barrier for investment in new pathways. These are not already fully integrated. And so this we can discuss. But when we want to come quickly to build big volumes for replacement from fossil, there is no other way to use this mass balance attribution. And we estimate that not only ISSC certificates, but all certificates come together to something like close to 1 million. And it can happen in the next 5-10 years that the share of bioattributed will be higher than bio-based. And so that was the reason why we also put this in the report to give you a deep information on this market.
Michael, before you go to the regional distribution, we have two more questions. So we have one, is it planned to verify the biogenic carbon content of bio-based materials with regard to the Green Claim Directive in the future?
Yeah, I will make short answer because we have only 8 minutes and we have still some interesting slides. A very short answer, this all has to be discussed. It's also a question in the bio-based, in the quota system, because this bioattribution, you have not only bioattribution, you have the same concept for recycling. And it's also a discussion in the Commission, if you will fulfill the recycling quota in packaging, can you also use chemical recycling and mass balance attribution? And it will happen that it will be, is it not finally decided, but 99% we expect that it will be accepted to fulfill the quota to use chemical recycling and mass balance attribution. So that means the door will be open for those for this concept, and the final decision will be in the next month. But we're expecting the market will open for that. So it's mainly happened in Europe so far. So the concept was born in Europe from some leading chemical companies in Europe. And so we see here at the moment, Europe is leading here. And here you see also the leading companies. BASF has invented this concept, I think, in 2013, something around. And you see here that most of the big chemical companies in Europe are using the mass balance attribution system already for their clients. And yeah, so before we stop, I have to show you also 2 examples how the report looks like. Here's an example for polyethylene, for example, and also one building block. You see here in the report, in the table, exactly who is producing it at which location. You see the development over time, and you see also a long test describing who is producing it, the history about it, and so on. And this will every year expanded. So you have the full overview on all the 17 polymers and building blocks, who is producing at which location, which volume, time frame, and so on. So I think this is a very useful information, especially if you are thinking in you're using a supplier, you're looking for a supplier, or you want to invest in the sector. You see, for example, with PE here, Neste is producing it, and UPM is producing it, Sabic is producing it. So a lot of very high value information. And the same is true when you look into companies. So this is first the building block deep dive, the polymer deep dive, and then we have in addition a deep dive per company. And here the example Braskem. You see here also the history, when it started, what joint venture was taken, what was the first clients, and also then the production capacities of Braskem at different locations. So I think these are very high value information, and we have here just put two examples that you get a little feeling what you can expect if you buy the full report. And my last slide is, and then we have 5 minutes for the last questions, is that we have two coming conferences, mainly the Renew Material Conference in Siegburg, with more than 500 participants on bio, CO2, and recycling. But the main focus will be on bio here. And the second day is only for, we call it here, fossil-free plastics. This name we are using because automotive sector, other sectors using this term. And we expecting here a lot of brands because we have 22 presentations on alternatives to fossil polymers, mainly bio, but also some CO2 based and also some from chemical recycling. And so if you want to show up here to find some supplier or clients, this is a great place to go. It's between Frankfurt and Cologne, station for the high-speed train, so very easy to reach. And for recycling, we have another conference which is mainly on advanced chemical physical recycling coming in November. But for the December event, this is the biggest event on this topic in the next 6 months. Okay, so we have time for a few questions. Pia, you can also select if you want to answer to some questions. Please select them because we cannot answer all. But if you see an interesting question, just take it.
Yeah, we just have 2 more PLA-related questions, but how much costs PLA approximately for technical uses per kg? I do not have a number in mind by hand right now. Do you, Michael?
It's also depending on the quality, what is technical application. So and in PLA, the last year the price was relatively high because the capacities was not big enough. Meanwhile, it's the other way around. The capacities are higher than the production. So I think the prices went down the last 2 years. But this is the information which is so sensitive, and also US has impact now on this price level that we have to do here special research. It's not a good idea to put one number now here.
Okay, yeah, but I just saw
the pricing. Thank you.
number.
Thank you, Jake. Here you can take a look to the price data, and we hope that are the recent ones. But thank you, Jake, for this information.
Yeah. Thank you.
Then the multi-layer water bottles, is this a question we can answer here now? I think there are both there. There are multi-layer and also pure PLA bottles, depending also on the content. Is it sparkling? Is it a fruit? So in sparkling or milk, you need some multi-layers, but there are also some bottles with the pure PLA bottles. So for Europe, it's mainly depending what happened with the Commission now. If you look to policy frameworks, there are about 10 new regulations, directives coming, all with impact on the bio-based polymer market. They will be developed till end of the year, perhaps also till start of the next year. And there are also, for example, discussions on LCA methodologies, whether you can show the carbon uptake of your crops also at the factory gate. Their teams from Nova and RCI are in this top PEF committee. And all of this development taking place this year will have a huge impact on the acceptance and framework in Europe. If the Commission will fail to create a good framework here, then we see that development is going strongly to Asia and Middle East. If we are able to make a better framework, we see that investment come back to Europe. So this year is an exciting year for Europe, whether we can be part of this revolution to bio-based polymers or not. And I hope it will work because the Commission is aware the strong competition to US and China. So they have learned that creating demand is the main issue. And we had just a meeting with the Dutch government 1 hour before, and they also make a lot of new concepts in the Netherlands. And here's also the crucial part, creating demand for the right solutions. And if this is understood in Europe, and this can be done by single capacity directive, by packaging waste regulation, by automotive regulation, so there are a lot of possibilities to create demand. There was the discussion in the Commission 2 years ago to have a 20% quota in almost all applications. If this would be reality, then we have a huge market pull, but it's not yet the case.
Okay, then we have, maybe you can answer it shortly, the question.
Yeah.
Last one, is there enough bio-naphtha available to fully switch from fossil to bio-naphtha?
Yeah, not yet. If you want to, if you sold to the whole chemical sector and you want to replace fossil carbon here, then biomass is limited to do the full job. But the good thing is also in naphtha, we can make naphtha from CO2. In US, there are companies offering CO2-based naphtha already. We will see as a side product from the aviation fuel production also some CO2 naphtha. And we can also make naphtha from chemical recycling. And if you take this naphtha sources, bio, CO2, and recycling together, then we can, in principle, replace all fossil carbon. But biomass cannot do it alone, and the biomass has not to do it alone. Okay, I think we can have a last question, but then we see also participants are dropping already. Thank you so much for the time. Thank you, Julia, for this comment. And so if you need more information, please go to our renewable-carbon.eu page to publications. Then you can download the free of charge report. If you not just need an overview of data and trends, this is enough for you. You can be very happy with this free report. If you need more for investment and for your macro business plan to your supplier and clients, then you please go to the commercial version. There you have a lot to read and enjoy the report. And many thanks to Pia and her team to make this report possible. And we make an update every year. And Pia and the team is working the whole year to collect data. And if you have your own data and they're missing here, please send us the data. We are very happy to get additional data all the time. Yeah. Thanks a lot, Pia. Thanks for the high participant number. And and let's hope that the framework in Europe will improve this year. Have a nice day.
Bye.